Us tonight for the Notre Dame Club of Washington, D.C.'s 2024 Hesburgh Lecture Series presentation. This evening, we are thrilled to welcome Professor Patricia Culligan, Dean of Notre Dame Engineering. Prior to joining Notre Dame faculty, Dean Culligan was Chair and Carleton Professor of Civil Engineering and Engineering Mechanics at Columbia University, as well as the Vice Dean of Student Affairs for Columbia Engineering. Throughout her career, Dean Culligan has been recognized for distinguished contributions to expanding the boundaries of geoenvironmental and sustainability engineering to enhance human health and the environment. In 2024, she was elected to the distinguished membership of the American Society of Civil Engineers, the highest honor of ASCE bestows. This evening, Dean Culligan will speak to the main research areas in which Notre Dame College of Engineering is focusing right now to be a force for good in the world. This evening's presentation will include bioengineering and discussion on bioengineering and life sciences, equitable energy transitions, and computational sciences, and of course, AI. Dean Culligan will speak for 45 to 60 minutes. She may be shorter, she may be longer, and then she will entertain questions from the audience. Dean Culligan, thank you for joining us. Welcome, and we look forward to your comments.
Well, thank you. Thank you very much, Rick. I'm actually going to start from when engineering was founded at Notre Dame in 1873 and work my way up to where we are today. And when he said 45 to 60 minutes, he was joking. It's going to be twice as long. No, but I promise I will try and be done in 40 minutes so we can have some nice conversations. But before I start, I really wanted to thank the Notre Dame Club of Washington, D.C. for allowing me to present to you tonight. It's a real honor. I met some of you outside in the reception, and I hope I get to meet more of you afterwards. But it's really great to be here. And I've been accused of bringing the South Bend weather with me. This is not true. It is much colder in South Bend, and we have snow and ice on the road. So you should count yourself lucky. But before I start, I really wanted to thank Maggie and Richard, Rob, Alexander, Mary, and Irene, members of the Notre Dame Club of Washington, D.C. that put this event together and enabled us all to be here. So I'm just going to start, as I said, with the history of the College of Engineering. It could just be me, but I find this quite fascinating, so I hope you do too. I'll talk about where we are today. I'm actually going to talk a little bit about our undergraduate aspirations as well as what we're doing in research. And then sort of just, I've got one slide that sort of talks about our future aspirations, which is more about how we're going to fit in with the strategic framework that the university announced, the 2033 strategic framework. And then we'll open the floor to questions, and please feel free to question me on what I presented. But if you have any general questions about Notre Dame engineering or Notre Dame in general that you think I could answer, I'm opening to giving it a shot. All right, so civil engineering started in Notre Dame in 1873. It was the first engineering program that was introduced onto our campus. And this was only 31 years after the university itself was founded. And it was quite deliberate at the time. The university wanted to train, it was young men then, to actually go out into society and provide the services that were needed for society to flourish. And we still actually are committed to that mission, educating young people to go out into the world and to serve society. Civil engineering was a program that was started initially because they were the services that were needed: roads and railroads, other transportation systems, and water. The first professor of engineering was actually a civil engineer like myself. He was British, like myself, so that's sort of interesting. And he came to Notre Dame via Canada. And like many professors of engineering at the time, in the US, and we're one of the oldest engineering programs that was founded in the US, and we're the oldest engineering program at a Catholic university, but there were others that were beginning to flourish at the time. So like many engineering professors at the time, he was deeply engaged in actually practicing engineering for his local community. So Arthur Stace was actually the St. Joseph, where our university is located, the St. Joseph County Surveyor. Round about the same time, Reverend John Zam was appointed vice president of Notre Dame, and this was a real game changer for the university. He was only 25 years old at the time when he took this significant appointment on. And he had a couple of aspirations for our university. The one was to transform Notre Dame from what was really a university that was just serving a local population into something that could serve the entirety of the US. So he wanted to transform the platform that Notre Dame stood upon. But he also wanted to bring science and engineering to the campus. And he was heavily committed to research. So he wanted to bring science and engineering, not just from an educational perspective, but also to introduce research into the foundational goals of our university. So in the 1880s, the Zam Special came into being, and I actually think this is a wonderful part of our history. So in order for Reverend Zam, Father Zam, to bring students from all over the country to Notre Dame, he really had to provide transportation, particularly from the West and also into Mexico. So the Zam Special was actually a railroad car that was built for this transportation purpose, and it would bring students from Mexico, from the West Coast to our campus. Not just Notre Dame students; it would actually bring St. Mary's students, and Father Zam himself would be the chaperone. Just to give you an idea, at that time it took 3 days to get from Denver to the South Bend campus. And this enabled the students that were committed to getting an education at Notre Dame to get to the campus much more effectively. I think this predates Hogwarts Express. And this is totally something as a community we need to embrace as special. We were the first campus to have electric lights. Thanks to a collaboration between Notre Dame and Edison, Tom Edison, who actually provided the generator to allow the campus to be lit. And this shows a picture in 1886 where 12 electric lights were actually placed around the head of the statue of Mary to form a halo. In 1882, and this is thanks to Father or Reverend Zam, the Science Hall was established. And this was established where we would all now see the La Fortune Center. So it was that the first Science Hall was established. And that's where science experiments were conducted, some of the first research, and engineering got the basement. So engineering, mechanical engineering was actually taught in the basement of Science Hall once it was established. If we fast forward a little bit, Reverend Zam's younger brother, Albert Zam, actually came to the Notre Dame campus, and he was initially an engineering student, and he later became a professor, and he pioneered a lot of work in aeronautics. A lot of the foundational work that's been done to spur aeronautics forward in our country was actually conducted on our campus under the direction of Albert Zam. And this is a painting that shows gliders that he launched from the roof of Science Hall that actually carried men. Now, who would get on that glider? I don't know, but some brave souls did. He wanted to actually launch the gliders from hot air balloons, but they were sane enough to stop that project. Not quite sure whether the gliders from the roof was any better, but these are some of the first aeronautic flight that was logged in our country, happened on our campus. In 1899, the first wireless transmission, long distance at the time, also occurred on our campus when Jerome Green, who who was studying physics and electrical engineering, actually hung a large antenna on top of the Basilica of the Sacred Heart and transmitted to the St. Mary's campus. So long distance at the time was 1.5 miles away. Today, our Wireless Institute is actually a leader in 5G and beyond technology. And they have a $25 million National Science Foundation grant to push forward the next generation of wireless. So that's an area where we established preeminence a long time ago, and we continue to move this forward. So we got our first engineering building round about 1931, a little bit later, when John Cushing, and many of you may be familiar with Cushing Hall, actually gifted funds to establish the Cushing Hall of Engineering. And that gift was $300,000 at the time. And he wanted that $300,000 to be put towards the immediate needs of the College of Engineering to meet the expectations of the future. And we still occupy Cushing Hall. It's still part of our engineering infrastructure. This is a modern day picture of Cushing, but I thought you might be interested in this aerial photograph that was taken when Notre Dame played Purdue in 1946. I believe we won. But this actually shows the campus at the time. And I'm going to step away from the microphone. Apologies to you online. That's Cushing Hall on the south side of the campus, and probably as far east as the campus had gotten. And right now, Cushing is in the dead smack middle of our campus. So our campus has grown around the first engineering building. So we fast forward a little bit. We started to establish our presence in graduating students that went on to excel at research. And this is Percy Pierre, who got both a bachelor's and a master's degree in electrical engineering from Notre Dame. And he went on to get a PhD from Johns Hopkins University. And he was actually the first African American to earn a doctorate in electrical engineering in the entire country. And he's had a very illustrious career. He was elected to the National Academy of Engineering for all of the contributions that he made, and that's like the highest honor that you can get as an engineer in this country. So Percy is one of our alum that we're very, very proud of. And we have very, very many alum that we're proud of. Believe me, if I put all of the alum in this slide that we're extremely proud of, we would be here until tomorrow. But there are more alum on our timeline, and many, many more out there, including in the audience, that have contributed to making Notre Dame engineering what it is today. In 1971, the first undergraduate women joined the engineering college. Mary Ann Proctor was a transfer student from St. Mary's College, and she enrolled in Notre Dame. So she was among the first group of female undergrads to pursue an engineering degree at our university. By 1974, that's just 3 years later, there are 26 women in the College of Engineering. Today, about 40% of our undergraduate population of 2,000 are women. So we've gone from 1971 to a significant fraction of our undergraduate population being female engineers. In 1974, we had the first Notre Dame astronaut, James Weatherby, who graduated from aerospace engineering, actually commanded the space shuttle Endeavour in 2002 during an 11-day mission to the International Space Station. We then started to expand our building footprint. So in 1979, the Fitzpatrick Hall of Engineering was built. This was a gift from the Fitzpatrick family, and it was dedicated and named for Edward Fitzpatrick, who was a 1954 graduate of civil engineering. And those of you who are familiar with engineering on our campus will know that Fitzpatrick Hall and Cushing are now joined together forever, because Fitzpatrick Hall was literally added to the back of Cushing Hall. And as I said, that is right bang slap in the middle of our campus right now, because the campus has extended further south and the campus has extended further east. Okay, we saw a significant facilities expansion from 1991 to 2016, and I've got a couple of examples here. The Hesburgh Laboratory, which the Henry Hesburgh family helped us establish, was built on the more northern side of the campus, and that contains a lot of the work that we continue to do in aeronautics and more broadly in fluid mechanics. Stinson-Remick Hall, the Stinson-Remick families, as well as the McCourtney families, helped us establish that, was built further south of Cushing Fitzpatrick. That's where we do a lot of the work in electrical engineering. That's where we have our nanofabrication and clean room facility. And then the McCourtney Hall of Science and Engineering was established further west on the campus. That's a joint facility between science and engineering that houses a lot of the research we do in chemical, chemistry, and biomolecular engineering. And that's a 200,000 square foot facility that is predominantly research at this point in time, shared with our colleagues in the College of Science. In 2021, we opened the Engineering Innovation Hub. Those of you who have been to campus recently will have seen this. This is actually in the first floor, I would say, is the ground floor of Fitzpatrick. And it's a state-of-the-art 10,000 square foot facility that provides experiential learning and advanced manufacturing training and an environment for our student clubs. Predominantly for undergraduates, but it is used a little bit by our graduate students. But for people that were used to Fitzpatrick before this facility went in, and they walked into Fitzpatrick and saw this facility, they were like, a spaceship has landed, because it is really an incredible modern state-of-the-art facility in a building, that was established some years ago. But we've made sure that you can look into the EIH, as we like to call it. So those of you who are on campus and want to walk through our Fitzpatrick Hall, I would encourage you to do this, because we put giant windows in and you can look in and you can see all of the state-of-the-art equipment that our undergraduates are using. And you can see our undergraduates taking advantage of this. We also, besides being recognized in wireless and aeronautical, established quite a presence in energy from our first mission to try and train the next generation to go out into the world and provide the needs of society at the time. And this is just an example of some of the recognition that we've got for the leadership that we provided in energy, both in education and in research. Daniel Murfield, who is currently the CTO of Q-Cells, and she graduated from electrical engineering, was actually elected to the National Academy of Engineers a few years ago for her leadership in advancing renewable energy. So that's a recent example of one of our graduates that was elected to this prestigious honor. Okay, something that those of us in research are super excited by might not excite so much others, but in 2023, Notre Dame was selected to join the Association of American Universities. So our universities are ranked according to their research productivity, and an R1 university is the top ranking you can get, but there's another level. You can get into this club, and this club is by invitation only. And it really signifies that you are among the top research universities considered to be an upper tier. And it's only the presidents of the other universities that allow you in. And so if you're not in the club, which we weren't until 2023, you're like, nah, who wants to be in that club? It doesn't mean anything. But under Father Jenkins, in 2023, we were admitted to this prestigious club, and I've got to say it's a huge honor for our university to be recognized in this way. And you can trace this all the way back to Father Zahm, when he became the vice president in 2025, saying we want to be a national presence, but we also not only want to educate students, we want to be involved and engaged in research that matters. So this is the end of a very, very long journey that we've taken, and it is something that has made a big difference to us. So right now in 2025, we're opening another research building, a second McCourtney Hall. And this is about the future of health at the crossroads of science and engineering. And it's another building that we're sharing with our colleagues in the College of Science. And here we're recognizing that the boundaries between science and engineering are blurring. And a lot of the discoveries that we need to make to advance human health, to support environmental health, even to support the health of our societies and planetary health, happen at the intersection of science and engineering. So this building is about propelling our research forward in this area. And it was generously made possible by the McCourtneys. And it opened its doors, I think, in January 17th. And the picture you see below the actual building itself, and that picture is the building under construction, is Jen Tank. She's actually a professor in the College of Science, and she was the first person to move into that building. And this is a picture memorializing her and her students moving into that lab space. And we've been quite deliberate in the design of this building. It's all shared lab space. It's all researchers from different groups coming together, working bench side to bench side together, and their graduate students and their undergraduate research students get to share space too. So we're hoping this real intersection or crossroads between science and engineering will help us propel forward discoveries that can really ensure the future health of humanity as we continue to move forward into this century. So we actually now have 750,000 square foot of engineering space on campus. So we went from the basement of the science building to really expanding our footprint across campus. We actually occupy 9 separate buildings right now. They span from the north to the south, from the east to the west of the campus. So engineering at Notre Dame is everywhere. It's true. As one of our illustrious alum has pointed out, we need more engineering. Okay, so let me tell you where we are today. We have obviously grown considerably, from our origins. But as you know, our first-year students don't come into any of our colleges and schools, with the exception of Mendoza College of Business. But they do declare what area they're interested in studying. And so right now, on average, we have about 500 of the incoming freshman class saying that they want to study engineering. And we have in the sophomore, junior, and senior about 1,500 students. So in total, we have about 2,000 engineers on campus. So that's like 25% of the undergraduate population right now is engaged in one of the degrees that our college offers. We actually have about 740 graduate and postdoctoral scholars on campus. The majority of the graduate students are PhD students. There's about 650 or more PhD students, and the rest are post-PhD, and they're generally on their way to an academic career. We have 200 faculty. About 150 of them teach and do research. About 25 just teach, and the other 25 just do research. And then we have about 100 staff. So we're a community of about 3,000 people right now. So we're a significant tour de force on the campus of Notre Dame. We offer 8 undergraduate programs. One is computer science. It's one of our most popular majors, and the others are all accredited engineering degrees. So our 2,000 undergraduates are interested in pursuing, in general, one of those 8 programs. And we offer even more graduate programs because in addition to the disciplines where we train the undergrads, we actually have PhD programs that cross different disciplines and train our PhD students. We also have a bioengineering PhD. We do not have a bioengineering department. Fun fact, we're the highest ranked bioengineering PhD program in the country that does not have a department. I think there's about 100 of them. So we're above average. So, yeah, so we're managing to cross all of the different disciplines together in ways that are I think are really important and really interesting for the future. The class of 2028 that we welcomed to our campus, we welcomed about 491 undergraduates. About 95% of them will stay in engineering, but we'll gain students from other colleges. So we'll probably end up around that 500 number. As I said, 40% of them are women. That's well above the national average. And as a commitment to our pathways to Notre Dame, which many of you may have heard about, our commitment to bring students to our campus from all four corners of society. About 18% of the people that are coming into our college are first generation. And that for us is great, and it's super important. If you go back to the origins of engineering, where we really were training people that came from all over the country, and many not from very wealthy backgrounds. We were bringing them to our campus, and it's been a continued mission of us. If we look at the engineering graduates that are coming in, we had about 168 join our community this fall. 30% of them are women. I would like to see that number higher, but interestingly, that's well above the national average for women that are coming into the PhD programs. That's mainly what our graduate programs are about. 44% are domestic and 56% are international. Nationally, if you look at PhDs, it's about 30% domestic, 70% international. So we are attracting some really talented domestic students, and that's super important for the future of the United States, including in areas that speak to national security. But what's interesting about the 56% international students is we actually have more international students in engineering than Kia does. Saying that while I'm standing in the Kia space. Because we have so many international students coming to do graduate studies on our campus. So that makes our graduate program and our undergraduate program and our community in general a very, very rich community where people from a lot of different backgrounds and perspectives can come together and study and propel knowledge forward. If you just look at the trends, I said we've grown, and I just thought I'd put this up there so you can just do like a decadal benchmark of where engineering is going at Notre Dame. Our undergraduate enrollments increased by 17% over 10 years. We've grown our graduate student population significantly. As I said, that's mainly the PhD students, and it's growth in our research that has got us into that prestigious club that we're now super proud to belong to once they've let us in the door, the AAU. Our faculty's grown too. Our faculty has grown at a greater percentage than our undergraduate students. We really do want to make sure that the faculty-student balance remains where we all want it to be, about 10 students to every faculty, so that we can offer the sort of quality of education that we want to. Our staff has grown more in the admin than the research, but not as much as the faculty have grown. And our research expenditures have actually exploded. So we're able to do more and more research, and we're able to get more and more funding for that. And part of that is the interdisciplinary buildings that have opened up on the east side of our campus that bring the scientists and the engineers together. Because when you bring these teams together, the type of problems they can solve is bigger, and then the type of federal funding that they can go after to make that progress that is necessarily just gets elevated. So our research funding has grown considerably. So we're very, very proud of these statistics, and we're going to continue to push these upward and onward as we move into the next decade. So you all know that Father Bob became our 18th president. I'm the 18th dean, by the way. So he and I both share the lucky number 18. He became our 18th president last year. And he sees Notre Dame as a bridge builder. And, what could be more important today in society? And he also wants Notre Dame to be an ever greater engine of insight, innovation, and impact. But I have to say, when he gave his inaugural address, those of us who were engineers in the audience and those that were engineers online, we like this person because we build bridges and we like engines. So we were going to get T-shirts printed with his face on it, with Notre Dame engineering for Father Bob. He stopped that when I suggested it to him. But anyway, I think we clearly have a president that's committed to propelling Notre Dame engineering forward. Bob the builder. We could try that. So what I want to do, I don't actually have that many more slides, so maybe I'll finish before the 45 minutes. I just wanted to go through what some of the things that we're looking at right now as we look to the future. I'm going to say near-term future, not the next 100 years. I don't have the ability to predict where we're going to be 100 years from now, other than larger and better. But what we've done on undergraduate education, one of our goals here is to provide an unsurpassed undergraduate engineering education, but we're really thinking about how to educate the engineers that are going to be able to uniquely serve a world that is in deep need. I mean, there are a lot of challenges out there that our Notre Dame engineering graduates need to be prepared not only to address, but to lead in addressing. So in the gray boxes, you'll see, what is generally provided. We provide at Notre Dame the core curriculum, formation of mind, body, and spirit. And there are other colleges and universities that have a core curriculum. It might not be as unique as our Notre Dame core curriculum, but they have a core curriculum. Of course, when we're training engineers, it's important to everybody in this room that we provide them with mastery of engineering skills. We're not going to graduate engineers that are not capable of doing the engineering that they're trained to. And ABET, our accreditation board, assures us, is there to assure everybody in this room that the engineers that we graduate on other campuses where there are ABET accredited degrees have that mastery of engineering skills. But if you think about what is needed to lead and what is needed to solve challenges, there are other things that our students need to gain while they're undergrads in our college. Problem-solving skills. They need to develop professional skills. They're going to be interacting with people from all corners of society. They need to be critical thinkers. They actually need to start to have multidisciplinary skills, and they need to have what we call convergent thinking, being able to pull different threads together and seeing what happens when you bring in knowledge from different areas, from different people, from different countries, et cetera. And it was mentioned at the beginning, computational and data science literacy is something everybody needs. So it's the green box that we're focusing on when we say Engineering Learning Plus. We want to be able to provide all of our engineers this Learning Plus experience. And so we're actually moving ahead with doing this by actually providing them experiences outside of our curricula. I mean, some of these skills are obviously embedded in the engineering courses and the labs and the design projects that our students are undertaking, but there are things outside our curricula where they can gain skills that they are not going to learn in a classroom or lab or working on a guided design project. So they can learn a lot by engaging in community, industry, or internship experiences, and a lot of our students are already in this area. International study abroad is something where they can also, sort of gain cultural competency. They can see how things are done in other countries. They can experience being somebody that's not at home in their own country. Our clubs and professional societies provide a lot of the leadership skills that our students need. And then research. This is something that we've actually started to try and make a lot more accessible. So the Engineering Learning Plus is really saying to all of our students, if you want to have experience in any of these areas, we'll ensure that you're able to have that experience. Now, there are some students graduate with experience in all these areas, and some maybe just want to, but right now we want to make all of these experiences accessible to every single one of our undergraduate students. And I put this up here to actually show you when our students get into the clubs, as well as the professional societies, and they have the opportunity to engage with other students, they really excel. And these are accolades that our undergraduate student clubs got just this last year. So we had a group of students that got engaged in designing an AI-controlled boat. This was a regional competition that ran for the first time last year, and it was run by an arm of the DoD. And they came to campus. They said, "Would you mind taking part in this?" And we got together a group of students. They were enthusiastic, and they walked away with first prize. You know, our civil engineering students, those great civil engineers that really started the engineering program off, actually, when they went to their regional competition, walked away with 7 firsts. And they've got in the back the concrete canoe. I have to confess, when I was undergrad, I did the concrete canoe. It's actually an interesting experience. You have to build a canoe out of concrete that floats, which is straightforward because you put ballast in it, but then you have to row the concrete canoe. And that's when you figure out whether your lines are straight, whether you've not quite got the alignment perfect. And that's actually when you lose this competition. It's actually rowing the concrete canoe and not building the concrete canoe. And our Notre Dame rocketry team actually just took away the NASA first team for their rocket launch last year. So these are experiences that are not just about design, build, operate. They're team building experiences. They're opportunities to, sort of compete together. They're opportunities to build conference. They're opportunities to really think that you're an engineer, which you don't necessarily always get in the classroom. So this is just an example of the type of experience we want to make sure that all of our engineering undergraduate students can engage in. And the other thing is research experiences for undergrads. And we introduced a system this year where all of the faculty that were offering research experiences had to advertise them. What a great idea. Because previously, if you wanted a research experience with a faculty member, you had to be brave enough to knock on their lab door, or the faculty member might see you were doing well in her or his class and say, "Hey, what do you think about coming into my research group? I see you might have a flair for this." And, that meant that a lot of our students didn't even understand how to get this experience, let alone what it might do. And, only about 10% of our Notre Dame undergrads go on to graduate school. So we're not talking about just offering this experience to the small number of students that want that. Research gives you critical problem-solving skills. It teaches you that you have an idea and it's not a good idea. Like, it teaches you that a lot because you always have to go back to the drawing board. It also teaches you to think about, is the knowledge that you're generating, is it important? Is it applicable? Is it something that is going to be useful to somebody? Or maybe you just want to do blue sky knowledge generation. There's nothing wrong with that. But there's a lot you can get engaging in research that you're also not going to get in the classroom. So the new system that we introduced in partnership with our colleagues in science called STRAND, and don't tell me what it stands for. We have so many acronyms, I just don't have the headspace to hold them all. But all of the faculty that have a research project advertise, all of the students that want to engage in a research project, apply, And then there's a matchmaking process that goes on. And the number of students engaged in research this academic year has exploded because of that. And I thought I'd give you an example. Here's a project that one of our mechanical engineering faculty is engaged in that has one of our undergraduate students. And they're sort of looking at an e-textile, a smart textile for prosthetic fits. Apparently, many folk that get prosthetics limbs fixed don't wear them because they're just so uncomfortable. Because they're sort of almost like a one size or, one manipulation fits all. But the idea of this research is to actually have the prosthetic adapt to the person's gait, to the way that they might move an arm or a hand, and then to actually allow it to learn and become more comfortable. So it's the type of research that our undergraduate students can get engaged in, and we hope they will. So the other thing I just wanted to touch upon is what we're doing to advance our research. And this actually came through an exercise that we conducted starting in fall 2020 and progressing on to spring 2021. I joined as a dean in fall 2020, and I promised myself and the community that we would achieve more than surviving COVID that year. Yeah, we would actually think about what the future of our college might be in many areas. So we looked at what everyone was doing in research, and we thought, how could we gather this together in a couple of areas where we could have more impact if we coalesced around a couple of themes than if we marched to an individual drum. And so we came up with 3 areas. One is human health and well-being. Another is the built and natural environment. We call it care for our common home after Laudato Si. And then the other is fair and equitable systems and technologies. And I'll just step through what we're thinking in each of these areas. But you'll see, as well as the 3 themes, we've also interested in just discovering knowledge for knowledge's sake. And then at the end, translating what the knowledge that we discover to action. And I'll try and explain how we're trying to advance that forward. I am really committed, as all of our faculty in Notre Dame Engineering and everyone that engages in research, to ensure that the knowledge that we generate actually gets off our campus and does real good in the world. Some of the statistics, if you look at medical knowledge that's advanced in some of our great universities, for example, only 17% of it actually makes it off the campus into a setting where people can benefit. And sometimes that takes 30 years. So we really need to, as a research community or as a community of academics, take responsibility for bridging what I call that knowledge to action gap. It's not just enough that we generate knowledge. We really have to think about how to get it out into the world and do good. So that's at the bottom of this continuum from discovering knowledge to translating it to action. So in the human health and well-being area, we have joined with our colleagues in ScienceGain, and we've created the Bioengineering and Life Science Initiative, BELLS for short. And there's a story to this. We were trying to come up with acronyms because we really wanted to join everything that was going on in bio with everything that is going on in life sciences. And I was committed to having engineering first. And so I came up with Bioengineering and Life Science BELLS, and the Dean of the College of Science, Santiago Schnell, who's just an absolutely wonderful person, could not come up with a better acronym. So we call it BELLS for short. But we have 80 faculty in this area across our 2 colleges who, they were in small clusters, but there was not one big umbrella that could bring them under one roof and enable them to do things that were quite special. But this is quite a crowded space, to be honest. There's a lot of research that's going on in bioengineering and life sciences. And we had to pick what Notre Dame could do that was unique and filled a gap. And as you know, we don't have a medical school. So we decided to commit ourselves to generating the knowledge that is necessary to enable the majority of the population, 90% that don't have access to clinics or medical schools, to enable them to have healthy lives, to enable disease detection outside of clinical settings, to think about, how we could treat disease outside of clinical settings. And there's an enormous amount that's going on in this space outside of clinical settings. I mean, I think we're all aware that Amazon is getting into the healthcare space. What does that mean? Kroger's grocery stores is getting into the healthcare space, CVS, so there's a lot going on in this area. And I think there are a lot of partnerships that we can form to really think about what the future of biomedicine looks like and what the future of human health looks like. So this is what we're doing in our bioengineering and life science. And the new building that opened is going to house this. So we're bringing together many of the faculty in the space under this one building with all of their PhD students, and this is something that the university, our provost, our VPR of research, and Father Barber also behind. So we're really excited about this move in human health and well-being. I just give you an example of something that's been going on in this area. This is Tom O'Sullivan and one of his PhD students that's now started a company called Nearwave. And Tom managed to create a handheld sensor for tissue imaging that's using infrared light that can detect breast cancer. And most importantly, it can actually detect how a tumor is shrinking after treatment. And that's super important. Because you really need to be able to do that more regularly than you can do by going back to a clinic facility and imaging, because that enables a pivot for the type of treatment that's being provided to the patients. So this is undergoing clinical trials right now. And he's working both within the US, but he's also expanding to work in South America, really as an early detection system. So this is a type of space that we want to get into. But for Tom to move this forward, obviously he needs engineering skills. He's an electrical engineer. This is where the technology came from. But he needs to partner with scientists to understand the biology of the tumors and to understand what he's detecting when he's looking at tissues and things. So this is the type of space that Bells is hoping to move into. Under our common home, we're focusing right now on equitable energy transitions. This is actually an interesting space. There's obviously also a lot going on in energy, but it tends to be divorce of thinking about other aspects of our environment that also need to be cared for. I think, like, we all know that batteries are essential for electric cars. That is good for getting people off combustion engines. But, some of the precious metals that are needed to make the batteries involve mining in remote areas of the world. And often the mining is done by children, so that's not an equitable solution to clean energy. Or it can decimate the environment, or it uses a lot of water. So we're trying to think of equitable energy transitions in two ways. One, a system of systems. You make the energy level better, but are you making something else worse? In which case, that's really not a transition that we want to think about. But the second thing we want to think about when it comes to transitions is, are we going to be doing this in order to benefit one community and we're going to disadvantage another? So one example is thinking about Africa's need for energy. Energy is the only way that Africa is going to get out of poverty. And are we going to say to them, you can't use a transition like gas, which emits CO2? You have to go straight to clean energy, which would be hugely difficult for them. So we want to think of transitions in multiple ways. So this is focusing on that. I think this is hugely important because I don't think we have a pathway to clean energy that has been mapped out and is viable right now. All of the pathways we see are short term, they're on political terms. They think about electric cars, they think about solar panels, but they don't think about the big moves that are needed for Africa to develop industry, which is the only way it will get out of poverty. So this is a space that we're tackling with the energy. Just want to give you an example that we just were awarded a National Science Foundation $25 million research center in the area of energy that's joint with multiple universities, and Jen Schaefer is a co-director of this, and they're looking at transformation of sustainable refrigerant life cycles, which is something you don't really hear talked about a lot, but it's also hugely important to a sustainable energy transition. So they've got a couple of things there that they've mapped out. So here's an example of some research funding that we've got to move this forward. The final area, the fair and equitable systems and technologies, is still under development. So I'm afraid, have a lot to talk about here. But we want to bring together our work in Internet of Things, cyber physical systems, and robotics. And all of these have a large component of computation and AI. So this is probably where we're going to see a lot of our computational and AI faculty coming together. But right now we're exploring whether we should do something in human-machine collaboration for humanity, because we've got a lot of faculty working in haptic assistance for people. This is a picture of research that's been done by Jane Cleland Wong. She's chair of our computer science and engineering department. She's using drone swarms to help in search and rescue. And she was on one of the "What Would You Fight For" videos, if you remember. So that's a human-machine collaboration that is helping humanity. We've got some faculty that are doing vine robots, which are driven by AI and computation. They're robots that are sort of bendy. They're like, I guess you get the idea with the vine, but they can go into situations where you have earthquakes, for example, and you've got collapsed buildings. It's like too dangerous to send in a human, but the vine robot can go in and sort of help with the search and rescue. So we're thinking of sort of this area as an umbrella where our fair and equitable systems and technologies is. But we're still trying to consolidate on a very solid research theme for this. Okay, just want to finish with the Engineering for Action Fellows. Okay, so faculty are like really bad at translating things into action. I'm going to admit that right up front. I'm one of them. But our PhD students are really good. And each of our faculty has about 5 PhD students. So imagine the PhD students being the agents for translating the knowledge that we generate into action. And 70% of our PhD students do not go on to a faculty position. The majority of them do not go on to faculty positions. Like, they go out into the world and do good with a different set of knowledge than our undergrads. So we've started this Engineering for Action Fellows, where the PhDs take, as part of their a 5-year training. They're with us for 5 years. They're with us for longer than the undergrads. And then we only let them go reluctantly. But they're going to take a year after they pass their qualifying exams, when they're close to finishing their PhD, to work with our Idea Center and think about, well, how do I translate this knowledge into action? And it doesn't have to be a company. They could be thinking about how does this, a new company, a startup, how does this disrupt Fortune 500 company, for example? What is a policy instrument? What is the economic instrument? So we're going to give them this sort of year of training, to see if they really can be the agents that allow sort of Notre Dame to be at the forefront of closing this knowledge to action gap. Again, we're doing this with science. I mean, I'm just saying the boundaries between science and engineering, at least at this level, are blurred so much. And we're doing about 20 students a year, but we would like to expand this. So that's at the bottom of the sort of the whole train that I presented. Just finally, I think you've all heard of the strategic framework 3033. I just put the things that we're trying to contribute here. Under health and well-being, we've got BELLS, sustainability, the just energy transitions. There's going to be computational ND, which will hopefully be announced in the next few months, which is going to pull together a lot of elements of engineering into that. Our poverty initiative is actually run by an engineer. So we're sort of deeply engaged in that. Tracy Chidusi Carrera is joint between engineering and the Keough School. And of course, we're very committed to the globalization of Notre Dame. As Father Zalm and the Zalm Express brought the West and Mexico to Notre Dame, we need to bring Notre Dame to the world, and we need to bring the world to Notre Dame. So we're committed to that too. And that's all I have.